It is Mr. Nicholas again. Welcome to this class. Today we're going to learn about linear motion. Linear motion. This is a topic in Form 2. Specifically, relative speed. And before we get into the details of the topic, we first of all have to familiarize ourselves with these terms. And the first one is distance. I know you know what a distance is. Distance is the amount of space between 2 points. Like now, if you have this end and this, the distance between them is this length. This length. So we can define distance as the length of a space between 2 points. Another very important term is speed. What is speed? Speed is distance covered over time. Speed is rate. It's the time taken for you to cover certain distance. Then the other one is linear. What do you mean by linear? Linear is a straight line. Linear is a straight line. Like now, this is linear. This is linear. This is a straight line. Another one is motion. What is motion? Motion is movement. Movement. That is what is called what? Motion. Movement. Then the other one is relative speed. What is relative speed? Relative speed, we can define it as it is the resultant speed at which two bodies move to great distance between them. It is the resultant speed at which two bodies move to great distance between them. And now we want to go directly to relative. Okay, we know that you have learned this in primary, whereby you're told distance is gotten by speed times time, and speed you get by, like now you make this a subject by dividing both sides by time. So speed will be distance all over time, and therefore time then will be what? Time will be distance times speed. We normally illustrate that in a triangle. I know you have come across this, whereby people draw a triangle like that, and then here they put distance, here they put speed, and then here time. Meaning that to get distance, it is s times speed times time. To get speed, it is distance all over time, and to get time, it is distance all over speed. So this one you learned before. And now, before we get into questions about relative speed, first of all, I want us to illustrate this with a scenario or a diagram. Like, for example, you have two bodies. You have another one at this end here, one at this end, and there is this distance between these bodies. There's this distance between two bodies. It will take little time for these bodies to meet. It will take very little time for these bodies to meet. How does that happen? That happens because if, for example, that is your distance, this is your distance, this is A, and this is B, and let us say you have a body, a bus which is moving, whose speed is 80 kilometers per hour. 80 kilometers per hour. It's a car whose speed is 120 kilometers per hour, and there is this distance between them. So, in 1 hour, the bus will cover 80 kilometers. The bus will contribute by covering 80 kilometers to bridge this gap. And also, the car will cover 120 kilometers in 1 hour. In the same 1 hour, this one will contribute by covering 80 kilometers. So that is 80 kilometers. The other one also will contribute because they are moving in opposite direction like that. The other one also will contribute by covering 120 kilometers in the same 1 hour. So what is the resultant speed of the two vehicles? You can see that all of them are contributing. In 1 hour, this one will cover 120 and this one will cover 80 kilometers. Therefore, in 1 hour, the distance covered by the two bodies or the two vehicles will be 80 plus 120, which will give us 200 kilometers. So in 1 hour, all of them will contribute the resultant distance covered or the distance covered by the two bodies. So the resultant distance now covered will be 200 in 1 hour. And that means now the speed will be, speed now will save the distance over time. So it is 200 all over 1 hour, 200 kilometers all over 1 hour. And that will give us what? 200 kilometers per hour. 200 kilometers per hour. So that is why now, if the bodies are moving towards each other, their relative speed, you add them. How are you getting this 200? You're just saying 80 kilometers per hour plus 120 kilometers per hour. So that is how we normally arrive to adding. That's why we normally add the speed when the bodies are moving towards each other, because they will take little time. Another scenario is whereby you have the same points, that is A and B. A and B. So you find that if the same vehicle is moving at let us say, for example, this one is at this point here, this is at point C, therefore, so this one is moving at 80 kilometers per hour, and this other one is moving at 120 kilometers per hour. So let us say you have two bodies, that is A, which is moving at 120 kilometers per hour, then another one is moving at 80 kilometers per hour, and they are moving in the same direction. So you will find that in 1 hour, there's this space between, this is the distance between the bodies, distance between the bodies, that is the distance between the bodies. So in 1 hour, this one will cover 120 kilometers to bridge this gap or to cover this gap. While this other one, in the same 1 hour, this one here will move away by 80 kilometers. This one will move away by 80 kilometers in 1 hour. So what is happening? The other one is trying to reduce the gap, the other one is creating the gap. So that means it is like this one is adding while this one is increasing the distance. This one is reducing the gap, this one is increasing the gap. So what do? It means that in 1 hour, it will be comparison of this. You can take this to be positive because it is reducing the gap, while this one is negative because it is increasing the gap. So in 1 hour, the resultant distance covered, we shall see whether it is, if it is positive, then it means that it has reduced in 1 hour. If it is negative, then it means that it has increased in 1 hour. So it will be 120 plus negative 80, which is equal to 40 kilometers. So you can see this is positive. So in 1 hour, the distance covered is 40 kilometers. And that will give us, if that is the distance, then it means that speed is equal to 40 kilometers all over 1 hour, and that will give us 40 kilometers per hour. And because it is positive, then it means that it is at the end of some time, then this vehicle will overtake this. But if, for example, this one that is running away had a speed that is more than this, for example, we can say that this one had a speed of 120 kilometers per hour, and this one has a speed of 80 kilometers per hour. What will happen? In 1 hour, this one will try to bridge the gap by 80 kilometers, and this one will increase by 120 kilometers. So what will happen? It will be positive 80 plus minus 120, and that will give us what? That will give us a negative of 40 kilometers. So you'll find that this gap will never be bridged. In fact, it will be increasing as time moves by. So that is what we mean by. So we can see that this is what we call relative speed. Relative speed. So when the bodies are moving in the same direction, the resultant speed or the relative speed will be the difference between their speeds. That is 120 kilometers per hour minus 80 kilometers per hour. And I believe now you understand why. Reason is the other one is increasing the gap, the other one is reducing the gap. So it will depend on which one is higher. But in this case, whereby they are moving in the same direction, I mean in opposite direction. So all of them are contributing to reduce this gap. The other one, so this one will be reducing by positive 80 because it is reduced. The other one is reducing by positive 120. So at the end of the day, in 1 hour, all of them will have reduced 200 kilometers. And that will give us speed of 200 kilometers per hour. That is what we mean by relative speed. So when the bodies are moving towards each other, the relative speed is gotten by adding the individual speed. If they are moving towards the same direction, that is another one is running, and the other one is trying to reach the other one, then the relative speed you will subtract. Good? That is very good. I believe you have understood. Now, we want to do an example. You know that this topic is very examining exam. And I promise you that it is going to be your favorite. It is going to be your favorite topic. It is a 10 marks question. And then now, I'm sure if you listen very carefully, at the end of the day, at the end of the lesson, you will be perfect in it. So I want you to give you another secret. So what we should consider here, we should always try to look for the time taken for the vehicles or the bodies, because use bodies to meet if they are moving towards one another, or to overtake each other if they are moving in the same direction. So we have an example, and the example you're told, a bus left Mombasa. Examples. Number 1. Yeah, so this is the question, this is the first example. You're told a bus left Nairobi at 8:00 a.m. and travels towards Eldoret at an average speed of 80 kilometers per hour. At 9:30 a.m., a car left Eldoret towards Nairobi at an average speed of 120 kilometers per hour. Given Eldoret is 400 kilometers, calculate A, the time the car arrived in Nairobi, 2 marks. B, the time the two vehicles met, 4 marks. C, the distance from Nairobi to the meeting point, 2 marks. Then D, the distance of the bus from Eldoret when the car arrived in Nairobi. So you have two bodies. And for you to understand this question, you can illustrate it using a diagram. That will help you to understand how you are going to tackle it. And we say that this is a linear motion. So the distance cannot be zigzag. It should be what? A straight line. So if, for example, you can take this point here to be your Nairobi. This is Nairobi. And here is Eldoret. So these are the two towns. And you're told the distance between the two towns is 400 kilometers. So this is 400 kilometers. This is the distance between the two towns. And you are told that there is a bus and a car. You are told a bus left Nairobi. So the bus is leaving Nairobi. Bus, this is bus. Leaving Nairobi. The time that is leaving Nairobi is 8:00 a.m. And the speed of the car, at an average speed of 80 kilometers per hour. 80 kilometers per hour. That is the average speed of the car. Then you are told at 9:30 a.m. a car left Eldoret. This one is leaving Eldoret. At what time? It is 9:30. This is car. 9:30 a.m. and speed is, so this is speed. And the speed of the car is 120 kilometers per hour. So this is what you need to understand. Then you are told, calculate the time the car arrived in Nairobi. Calculate the time the car arrived in Nairobi, the time it arrived at in Nairobi. So what do you need to know? If for you to get time, what you need is distance and speed. Remember this? Remember this, distance, time, and speed. So because you need time, it will be distance all over speed. So what is the distance? The distance is the entire, which is 400, divided by, what about the speed of the car? We are talking about the car. The speed of the car is what? The speed of the car is 120. So what is the time? So the time taken will be, use calculator, the time taken will be 400 divided by 120. You can do together. So the time will be 3 hours and 20 minutes. 3 hours and 20 minutes. So this is the time that the car will take to move from Eldoret to where? To Nairobi. That was just simple because you are calculating. You just needed distance and the speed of the speed of the car. But you're told the time the car arrived in Nairobi. You're told the time, at what time did it arrive. So this is the time taken. But you're told at what time did it arrive in Nairobi. So what we need here, we need to know the time that it took off. When did that car started the journey? It started at 9:30 a.m. and took 3 hours and 20 minutes in the way. So this will be 05. This one will be 12. It is past noon. So it is 12:50 p.m. So that is the time that the car arrived in Nairobi. I believe you have understood. We set the distance over time, we get time taken, and then we add the time that the car started the journey. Then the other question is the time the two vehicles met. That is what we wanted to learn. The time the two vehicles met. So I can still use the diagram. So we can say that. Okay, let me demonstrate. So you can see that the bus is starting at 8 a.m. and this one starts the journey later. After how many minutes? After 1 hour and 30 minutes. That means before this one took off, before this one started the journey, this one must have covered, the bus must have covered some kilometers within that time. So what is the time difference? So time difference is what? Time difference is 9:30 minus 8:00, which is 1 hour and 30 minutes. 1 hour and 30 minutes, which you can give in hours to be 1 hour and a half, because we know that 30 minutes is equivalent to half an hour. So this is the time that this one moved while this is at rest. So that means we need to cover, because this one was moving, we need to know the distance that it covered before this one started the journey. So how do we know? We know this is the time taken, and we know its speed is 80 kilometers. So how can we get distance? Distance is equal to speed times, this means times and this division. Speed times time. So speed is 80 kilometers times time. This is the time that this one was moving before this one started the journey. So it is, if you try it in improper fraction, it will be 3 all over 2. By this one, by this 40, that will give us 120 kilometers. So before this one started the journey, this one moved how many kilometers? 120 kilometers. So that at 9:30 a.m., the bus is at this point. The bus is at this point, and this one is just starting the journey. One thing that you have to understand is that if you want to use the relative speed, both bodies must be in motion. That is why I have to calculate for the distance covered by this vehicle before this one started the journey, because while it was moving for 1.5 hours, this one was just still. So we need to consider the time at which all of them will be at motion, and that is 9:30 a.m. And for us now to get the time the two vehicles met. So what we need to do, I told you that what you need to do, you calculate the time taken for the bodies to meet. So how do we do that? The time taken for the bodies to move. For you to get that, you need to know the distance between the vehicles. The distance that the vehicles should bridge. So the distance between the vehicle is, remember, from here to this point is 400 kilometers, but from here to this is 120 kilometers. So what about this distance that is between the vehicles? It is 400 minus 120, which will give us 280. So that will give us 280. It is 400 minus 120, which will give us 280 kilometers. Therefore, distance between the bodies, very important, distance between the bodies is 280 kilometers. 280 kilometers. Then relative speed. By now you know what we mean by relative speed. Relative speed. You can see that the bodies are moving towards each other, meaning that they are all of them contributing the same to bridge the same the distance between them. So how do we say that to get relative speed when the bodies are moving towards each other? You add, because all of them are contributing. You add their individual speed. So this one is 80 kilometers plus 120 kilometers. That will give us 200 kilometers. So it is 80 kilometers per hour plus 120 kilometers per hour, which will give us 200 kilometers per hour. So that is the relative speed. Reason, all of them are contributing to bridge the distance. Then, now time taken for the vehicles to meet is equal to distance between the bodies, divided by relative speed. Distance between the bodies divided by relative speed. That is, distance between the bodies, we say that it is 280 kilometers divided by relative speed, which is 200 kilometers per hour. So that will give us time. So 280 divided by 200. That will give us 1 hour and 24 minutes. 1 hour and 24 minutes. So the bodies or the vehicles will have to move for 1 hour and 24 minutes from 9:30 a.m. because that is the time all of them were in motion to the meeting point. So the question is asking the time the two vehicles met. The time the two vehicles, at what time did they meet? So when were they moving at the same, when were they in motion? They started the movement at 9, that was the time that all of them were in motion. And then now you add 1 hour and 24 minutes. That will give us, so they will meet at 10:54 a.m. That is the time that the vehicles will meet. How did we get this? What is very important here is the distance between the bodies. Distance between the bodies. The next thing is relative speed. If they are moving towards one another, then the relative speed is gotten by adding. And then now you divide to get the time taken for the vehicles to meet. So if you add, you will get what? So they met at 10:54 a.m. I believe you have understood that, because that was the most important part that we wanted to learn. Then the other one, you're told the distance from Nairobi to the meeting point. The distance from Nairobi. The distance from Nairobi to the meeting point. So let us say, for example, this is the meeting point. This is the meeting point. That is where the vehicles met. That is the meeting point. And they have met at 10:54 a.m. And you're told the distance from Nairobi. So there was this vehicle that moved from Nairobi like that. And we were never told whether it stopped or not. So we assume that it never stopped in the journey. It was just moving. So that is the vehicle that will help us to get this distance. Okay, so we are told, so what we do, we are using this vehicle that moves from Nairobi to this meeting point. So this is the time that they met, and this is the time it started the journey. So then we need to get the time difference, and then we multiply by speed so that we get that distance. There's different ways that you can do that, but I think this is the simplest. So what do? We look for the time difference. Minus 800, which is 54, and this one is 2. So we can change this into hours, so it will be 1/60. So this is now the time. This is the time. That is the time, and we know speed. Speed is 80 kilometers per hour. This is the time in hours, and speed is 80 kilometers per hour. So to get the distance equal to speed times time. So we will just say, okay, so I can divide 54 divided by 60. That will give me, this will give me 2.9 hours. 2.9 hours. So I'll just say 2.9 times speed, which is 80. And that will give me 2.9 times 80, which is 232 kilometers. 232 kilometers. So that is the distance between Nairobi and the meeting point. What have we done? We know the time at which the vehicles met. That is 10:54 a.m. We know there is a vehicle that started the journey, the bus, at 8:00 a.m. moving from Nairobi. So what do we need to do? We were never told whether it stopped. We assume that it never stopped. So we will say 10:54 minus 8:00, and then we get what? Time difference, which is this, and then we multiply by speed, and that will give us distance. So the distance from Nairobi to the meeting point is 232 kilometers. Lastly, you are told the distance of the bus from Eldoret when the car arrived in Nairobi. The distance of the bus from Eldoret when the car arrived in Nairobi. So when the car arrived in Nairobi, we know that they have different speeds. The other one is 120 and the other one is 80. So of course car will reach Nairobi first. So let us say this is car reaching Nairobi, and this is the bus. The bus is still on the way because its speed is less, and it has to take a lot of time. So what do? Do you know the time that the car arrived in Nairobi? Yeah, we calculated before. There was a time that we were told the time the car arrived in Nairobi. So the time the car arrived in Nairobi was 12:50 p.m. This is the time the car arrived in Nairobi. And we are told the bus started the journey at 8:00 a.m. and it never stopped. There was no time that it stopped. So we need to get the time taken. We need to get the distance covered by the bus within this time, by 12:50. What distance did it cover? So how do we do that? We will say 12:50 minus 8:00, which is the time that the bus started the journey. So this will be, then this one will be 4. So it will be 4 and 50 all over 60. I have to change this into minutes. So it will be 50 divided by 60. 50 divided by 60. It will be 60 times 4 plus 50. So this will be 290 all over 60. So this is the time in hours. And now to get the distance, I will say the distance now will be 29 all over 6 times speed of the bus, which is 80. That will give us 386.67 kilometers. 386.67 kilometers. So by the time the car arrives in Nairobi, this one will have covered this distance. So what is the remaining distance? The remaining distance, because you are told the distance of the bus from Eldoret. This is Eldoret. The distance from when the car arrived in Nairobi. So what do we do? So we shall say 400 minus 386.67. So it will be 400 minus 386.67. So that will give us 13.33 kilometers. So that is what is remaining, 13.33 kilometers. So by the time the car arrives in Nairobi, the distance between the bus and Eldoret will be 13.33 kilometers. So that is how we solve a question like that. That is how we solve. I can see that it is a 10 marks question, and I believe now you are able to solve. Now let us look at another example, example 2. So a bus left Mombasa at 7:00 a.m. traveling at an average speed of 80 kilometers per hour towards Nairobi. After 2 hours, a bus left Mombasa at 7:00 a.m. traveling at an average speed of 80 kilometers per hour towards Nairobi. After 2 hours, a car started and traveled in the same direction at 120 kilometers per hour. Calculate how far from Mombasa the car caught up with the bus. So here can do this. I still told you that for you to be able to answer this question, you have to illustrate using diagram. You have to illustrate using a diagram. And so you are told that there are 2 towns, that is Mombasa and Mombasa at an average speed of that towards Nairobi. So this is Nairobi. That is Nairobi. And you are not given the distance between the distance between the towns. And then you are told after 2 hours a bus left Mombasa. So bus left Mombasa at 7:00 a.m. traveling at a speed of the bus is 80 kilometers per hour towards Nairobi. So it is moving towards Nairobi. Then after 2 hours, the car started the journey moving along the same road, the same direction from Mombasa to Nairobi. So these are vehicles which are moving in the same direction. So this is Mombasa and this is Nairobi. So you can see that the car is starting after 2 hours. That is after 2 hours. That means the car is starting at 7:00 plus 2 hours, which will give us. So it is 7:00 plus 2:00 will give us 9:00 a.m. So this is the time that the car is starting the journey. That means there is this 2 hours difference. So what was happening within those 2 hours? One vehicle was moving while the other one was at rest. Therefore, we need to know the distance covered by the bus while the car was at rest in those 2 hours. Therefore, we know speed of the bus is 80 kilometers per hour, and time is 2 hours. Therefore, distance covered now will be speed times time, which is 80 multiplied by 2. That is 160 kilometers. So that is 160 kilometers. So when the car, if this is the car and it is starting the journey at 9:00 a.m., the bus is at this point. At 9:00 a.m., the bus is at this point. It is already on the way. So there is this distance between the vehicles. And that is what I told you to know. You first of all, you must note the distance between the vehicles so that you are able to calculate. So what will be the distance between the vehicles? This is the distance between the vehicles. This is the distance. That's why you are not even given the distance between the town. Because this time difference of 2 hours can create that distance difference. So the distance difference is, what is the distance difference? So the distance difference is this 160 kilometers. So therefore, for us to be able to, after 2 hours, a car started and traveled in the same direction. At that, calculate how far from Mombasa the car caught up with the bus. So how far the distance the car covered in order to catch up with the bus. So I told you that what is very important is, first of all, you calculating the time taken before the vehicles meeting, or before the vehicles overtaking one another or catching up each other. So we will say time taken is equal to distance between the bodies, distance between the bodies or the vehicles, between the vehicles, all over relative speed, We know the distance between the vehicle is 160 kilometers, and the relative speed, remember this one is moving away and this other one is trying to bridge the distance. So we say that if they are moving in the same direction, the relative speed you get by subtracting, because the other one is running, this one is trying to catch up. So the distance, this one will be negative and the other one is positive. So if you add, you get a negative. It's like the same as subtracting the relative speed. So the speed of the bus is 80 kilometers per hour, and the speed of the vehicle, of the car, is 120 kilometers per hour. Therefore, the relative speed will be equal to 120 minus 80, which will give us 40 kilometers per hour. So because the bodies are moving in the same direction, one is running, that's why we get the distance by subtracting. So that is one thing that you need to remember. So the time taken now will be 160 divided by 40. That's one by this. So that will give us 4 hours. So it will take the car 4 hours for it to do what? For it to catch up with the bus. And we know that it was starting, the car started the race at 9:00 a.m. So the time that it will catch up, you're told calculate how far from Mombasa the car caught up with the bus. So because we need the distance and we know the time taken by the car to catch up with the bus, what we need to do, we know the speed of the car. It is 120 kilometers. And it moved for 4 hours to catch up with before it catch up with the bus. So that means distance covered is equal to, distance covered now will be equal to the speed, which is 120 times 4. And that will give us 480 kilometers. So the car will cover for 80 kilometers in order to catch up with the bus. So that is how we do it. So what I just want you to know is that what is very important here is the distance between the vehicles, which now you divide by relative speed to get the time that the vehicle will catch up with another one, or the time the vehicle will take in order to overtake another one. Thank you.